Welcome to another video from explainingcomputers.com. This time I'm going to provide an introduction to the Python programming language. Now obviously in one video I can't turn you into a seasoned programmer, but what I hope I can do is to help demystify the art of coding and get you off to a good start. The Python programming language is freely available for a lot of different computer operating systems, and you can download what you need from python.org, where if we go to downloads, here I'm going to select Windows, and I'm currently on a Windows machine. And there you'll see we get to the next page. There are various releases available. I would just simply go for the latest release, and here I'm going to be using Python 3. So if you want to follow these tutorials through, make sure you're using Python 3. So I'll select Python 3. Currently version is 6.5, and if you keep scrolling down this page, keep going and going and going, you will get to the file section, as you can see there. And what we want here is the Windows x86 executable installer, which is over here. This is what you'll need if you're running a 64-bit version of Windows, which is what most people will be running these days. So I'll click on that, and we'll save that file. And with the download complete, we can run that. And we can do an install of Python. We'll do a standard install with all the basic options at their default settings. Yes, we want to do it Windows, we really do. And there we are, it is installed, so we can close that down, get rid of our web browser. And we should now find that in our menu, we have under recently added, we've got Python. You'll see we've got some manuals here, which is nice, and some documents. And the main thing we're going to be using is this, which is IDLE, the Integrated Development Environment. I'm going to drag that across onto our desktop, so we've got that available so we can find it. And if we run that up, we go into Python shell window, where we can start to either execute code directly or write our own programs. Now, I should say here, if you're running Linux, almost certainly you'll find you've got Python already installed. And in particular, if you're running Raspbian on a Raspberry Pi, you can just go to the menu and go to programming, and you'll see you've got Python 2 and Python 3 there waiting to be used. So again, we could click on Python 3 and Python's integrated development environment will run up. And indeed in the rest of this video, I'm going to be running my Python code and writing my Python code on a Raspberry Pi in Raspbian, purely because I've got IDLE set up here with some nice fonts and colours, so you can see it clearly on the screen. But everything I'm showing you here will work exactly the same in Python 3 on any Linux machine, or indeed in Windows. Right. Here we are back in the IDLE shell window, where if we like, we can enter Python code directly. So for example, I could enter the command print like that, and because we're printing in Python 3, we have to put what we're printing in brackets. I could put, for example, 10 times 20, close our brackets, press enter, it would execute that code, give us the answer 200. So you can use Python as a very sophisticated calculator, if you like, entering code to get results directly in the shell. But most of the time, you'll want to produce a program, you want to create a file. So here we can go to File and New File, and it'll take us through to the IDLE editor. And I would point out you don't have to write Python code in the IDLE editor, but it's a good place to start. And again, we'll do something nice and simple. We'll put, for example, print, open our bracket, this time open a quote, put a piece of text in, hello, close our quote, close our bracket. There we are, we've created a very simple program. And if we want to run that, we first have to save it. So we'll go to File and Save, and we'll save it here in Python code. You can save your code wherever you like. I'll call it test. There we are. And we can now run it, and we can run it in one of two ways. We can either go to the menu and go Run and Run Module, or as you might be able to see here, we can press F5. Here I'll press Run Module, I'm there already, and you'll see it'll go and run our program. It's printed hello. And we could now go back if we want to the editor window, and we could run this again. I'll press F5, it'll take us back to the shell and run it. Or we could, if we wanted, close that to shell down, go back to automatically there to the editor window. Again, if I press F5, it'll run the thing again and press hello. So you can work with this exactly as you want. Now, it's good practice when you're coding to put some comments in so people can work out what's going on, so you can work out what's going on if you look back at your code. So if I go back to the top here, I'll put in a hash, and a hash basically says everything that follows this is a comment. So I could write, for example, our first Python program. And that red text is appearing because it's after a hash. This will not be executed by the program. It's simply there so a human being can read it and see what's going on. Now, you will have noticed here I put hello in quotes because it was a piece of text. I just want to show you what would happen if I hadn't done that. If I take those quotes out, it would still be valid code, but if I save this and F5 to run it, you'll see what happens is it gives us an error. It can't actually find hello, because the problem is it thinks hello here is a variable. We haven't defined a variable called hello, but we could do if we wanted to, of course. So we can go in here and we'll do it with a comment as well. Let's be nice and neat. We could put define variable hello like that, and under there we could put in hello equals and welcome everybody, maybe with an exclamation mark like that. We've defined that variable there, and then therefore we can print it out at the end of that. So if we actually do a save again, why aren't I saving with control S? I don't care. Press F5 and it'll run our code and it'll print welcome everybody. It's actually using that as a variable. I should just point out in doing this here we've got hello with a capital letter there. If I'd happened to have had hello with a small case h on that, we'll just save that to show you, and if we run that with F5 you will see that it'll fail again. Hello is not defined. I just did that to make it clear to you syntax really matters. Small letters, large letters, small and uppercase really matters significantly in programming. Programming has to be just right. We'll put that back to a capital H, do a final little test here. That should now again work okay. Now, in this first piece of code we wrote, we defined a variable and then we printed it out. But there may well be occasions you want to get a variable input from the user. So how will we do that? Well, let's get rid of that and have a go. And we could put in a comment, say for example, ask the user for their name. And then we could define a variable called name, which will be equals to input, which is the function to get some input from the user. And we could then open up our bracket, open up a quote to enter a piece of text. What is your name? And we'll make it look neat on the screen like that, I think, as it prints it out. And that would ask the user to input their name. And then we could print, and maybe we'll print, I don't know, open up a quote, hello, close a quote, comma, name. And you'll see that print statement there has basically got two parts now. It's going to print the text hello and then the variable name. So if we save this and then we execute by pressing F5, it'll come up, let's move that up there, and it'll say, what is your name? I'll answer Chris. And if we press enter, it'll say, hello, Chris. Aren't computers amazing things? And because computers are amazing things, they can do extra things with this information. So, for example, there is a function in Python called len, which tells you the length of a variable string. So, for example, here I could therefore put, after this, maybe print, and something like your name has, and then we could finish it off and write len name, which will tell us the number of characters in the name variable, and then we put on the end letters like that, and there we are, finish it off, and there we are. If we now run that code, or save that code and run that code, and F5, it'll say, what is your name? I'll put in Chris, and it'll say, hello Chris, your name is 5 letters. It has worked it out for us. Again, aren't computers amazing? Now, as you probably noticed, all the variables we've been working with so far have been strings. They've been lists of characters, not numeric values. So I thought we'd take a look at what we do if we want to work with numeric values in Python 3, input them and do something with them. So I've written this piece of code here which basically asks the user for a number. We're going to have a variable called var, which is going to be input by the user, and then we're going to print your number was, and your number multiplied by 5 is, and that's going to be var times 5, which on the surface all looks perfectly fine, doesn't it? So we'll run this piece of code, press F5, it'll come up there, enter a number, or what should we do? Oh, I don't know, 27 is a good number, isn't it? There we are, 27, and enter, and it says our number was 27, number multiplied by 5 is, that's clearly wrong. That is not 27 multiplied by 5, that is the characters 2 and 7 reproduced 5 times over. And that's because when we use the input function in Python 3, it assumes we're inputting a string, a list of characters, not a numeric value. So there's various things we can do about that. One of them is to convert our variable into a value before we do something with it like a calculation. So I could, for example, here put int, which is the integer function, put a bracket in, put that round var, close the bracket. That will turn var into an integer value before it multiplies it by 5. So if I save that and F5, enter my number, 27. It'll work, that's absolutely fine, value of 135. However, it won't always work, because if I went back here and just run this again, and we say, what is my number? I'll put in, say, 27.4. Oh dear, it doesn't work. And that's because 27.4 clearly isn't an integer. So sometimes we want to work with numbers which are not integers. And to do that, we can make this into a floating point variable. We can put in float there, around there. If we just save that and run it again. And if we put in here our 27.4, that now would work 137. Let's put a decimal on the end. Now, it's worth pointing out that you don't necessarily have to convert your variables to values right at the end when you use them if you like. I could take that out, like that, and go back up here, and when we actually put the value in, I could put var equals, and then float, and then we could put brackets around the whole lot, and that would actually create a numeric value from the start. We just save that and run that again. Should be exactly the same result as last time, put in our 27.4. And yes, that'll work perfectly well. Now, that basically gives you some principles. This is not a very interesting piece of code though. So what I've done is to write another piece of code, which I've got hopefully over there. This is a slightly more potentially useful thing. This is a BMI, a body mass index calculator, written as it says in Python 3. And this basically asks the user to enter their height and weight, which are going to be floating point variables, where you'll input your height in the meters, your weight in kilograms. It'll calculate your body mass index then, which is basically your weight in kilograms divided by your height squared. And what we've got here is not height times 2, we've got 2 asterisks there, so this is height to the power 2, and it'll print out the result. So if we run this, there we are, it's come up. What is my height in meters? I think it's about, is it 1.86? I don't know, it might be. And what is my weight in kilograms is what, 71.3, I think. And there we are, it's given my BMI is 20 point and lots and lots and lots of decimals. That's worked, but it's not very neat. So if we want to make sure we make it a bit neater, we can use another function here. If we use the round function, put round in there and put brackets around BMI, and BMI, say, comma 1, will give us the variable BMI, but to 1 decimal place. So we put that in with one more bracket on the end to finish it off. Always get your brackets right, and file and save. And if we just run that again, I'll put in the same values, 1.86 meters and 71.3 kilograms, but the answer now will be a BMI of 20.6, which looks a lot neater. Now, you might be thinking, why doesn't it then tell us what this number means? And that's a good idea, but to do that, we need to look at something else, which is if statements. Well, here I am back again, and we're going to look at if statements, if commands. So what I've done is got a bit of code here. I've defined a variable called magic, and we've asked the user to input a number. It's going to be guess is the variable there. It's going to be an integer, and we asked them to guess the magic number, and we now want to see if they have input the magic number. So to do that, we'll use a nice if statement, and so I'll put something like if guess, which is what they've input, is equals the magic number, magic, and you'll notice here that I've used a double equals. If you want to do this numeric comparison in Python 3, you can't use a single equals, you must use a double equals. People often don't get that right, their if statements don't work, they get terribly sad, so make sure you use the double equals. So if guess equals magic, we'll then put a colon, and then when we press new line there, it takes us down to an indented portion where we can put what happens if is true. So I'm going to print, what I'm going to put, relations, that is the magic number. That looks an exciting thing to put, doesn't it? And there we are. And that for now will be the end of our code, I think. So we'll just have that. So I'll just file and save this. And if we run this, so if I press F5, there we are. What is the magic number? We know it is 7. So if I enter 7, it says, yes, that's the magic number. And just to prove that's true, if we go back and run this again, what's the magic number? I'll put in a 3. Doesn't give us anything, comes to the end. Now, of course, it would be useful to actually tell us it wasn't. So if we go, if guess equals magic, we're going to print congratulations. But we could then go down here and put in an else statement. So this is what happens if it's not true. So else, and then we'll put print, what shall we put? Sorry, that is wrong. Oh dear, that looks very sad, doesn't it? Never mind, that's what's actually happened down there. So if we now save this again, we run that. Missed it, didn't I? There we are. Save it again and run it. And what is the magic number? If I put in 4, that is wrong. And obviously still if we run it again, and what is the magic number 7? That is right, it's got it right. And if you're thinking to yourself, it'd be rather good if it kept coming back and ask us to do it again, it would. That would be a loop. We'll look at loops in a second. But just before we do that, I thought we'd go back to our BMI calculator. I've added some if statements in to show you things getting a little bit better. So BMI advisor we now have there. And BMI advisor is exactly the same code we had before. We enter the height and weight of the user. It calculates the BMI. And then we've got a set of if statements on the end here, which says if BMI is less than 18.5, it prints you are underweight. And then if that's not true, it goes on to say, well, are you in the middle category? It says if it's less than 25, you must be greater than 18.5 because you've got to this bit. It prints you are a healthy weight. And then it says, well, if you're not, therefore you must be overweight. So we've got two sets of ifs and elses here. The first one there, and then what's called a nested if and else statement following on from that. So that in theory will work okay. So if we just go and run that piece of code, we'll come back to where we were before. What is my height in meters? What was it? 1.86 and 71.3. There we are, all of a healthy weight. Isn't that good? But if I ran it again and we put different values in, and I said I'm a 1 meter tall, I weigh, I don't know, 400 kilograms, I'm clearly going to be overweight. And let's just to prove it does all the conditions. If I go back the other way, what is my height in meters? I'm 3 meters tall and I weigh 10 kilograms. I'm clearly underweight. So you can see we've got some working if statements there. You can hopefully see the syntax of how if works in Python 3. Now, another really fundamental part of programming is using loops, and particularly here I want to show you in Python 3 a while loop. So if I've set up basically a very simple piece of code here, I've just defined basically a variable to be counter, which is equal to 1. I'm going to use that in a second. And we'll now put in a while loop, which basically is in the form you put while and then you give it a logic statement. And as long as that logic statement is true, it'll keep executing the loop. So if I put, for example, while counter is less than or equal to, that's how you do less than or equal to in Python, the equality sign and then equal. If it's less than or equal to, say, 10, and then we'll do a colon, and then we'll tell it what to do inside the loop, which will be print and counter. And then we'll do counter equals counter plus 1. In other words, not plus 21, Chris, just plus 1. That will add 1 to the counter. So what this should do is, as you can probably guess, it'll say print counter, add 1 to it, keep going until it gets to 10, and then it'll stop. So if we save that and execute that code, F5, there we are, look, it's printed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as a loop, which is all very well, rather nice, and it shows us again a principle. Now, if you think back to the magic number program we had a second ago, where clearly a loop might have been quite useful, I've got our magic number program here, which has been slightly altered, and this basically says it defines our magic numbers to be 7, asks the user to guess what it is, but then rather than using an if statement here, it uses a while loop. So it says while guess, and we've now got an exclamation mark and equal, that means not equal to. So if you want to say something's not equal to something, exclamation mark and equals in Python 3. So while guess is not equal to magic, print that is wrong, try entering another number, and we have another attempt here at inputting the number, inputting the variable guess, and that will keep going until someone puts in the right number. So in other words, that will no longer be true because guess will equal magic, and therefore it will print congratulations, that is the magic number, and print goodbye. So let's run that piece of code. And as you can see, if we put the right number in, I'll put in 7, it'll just say congratulations, that's the right number as previously. But if we run the code, put in the wrong number, put in say a 4, sorry, that's the wrong number, try again, let's try a 9, try a 3, try a 5, and try a 1. We'll keep going until eventually put in a 7. Wonderful, we got the right number. You might be thinking that could get caught forever if you get it wrong. It could. If we actually press F5 there and run it again, what's the magic number? And I keep putting in the wrong number, I can get out of this by pressing Control and C. And Control C will crash us out to get us back to working on the code again, or we could just simply close down the window. So if you do get into an infinite loop in Python, either close down the window or press Control C. So, here I am back again for a final time. I just want to run through one more concept in this video, which is the use of something called a library, which is basically a command or a function that's not automatically available in Python. You have to load it in before you can use it. So far all the functions and commands we've used, things like print and while and things like that, they've all actually been available directly, but they aren't always there automatically. So say, for example, we want to use a function called time in Python 3. What we have to do is, first of all, import time. Time is a module that gives us various time functions, and it'd be sensible to put a bit of commenting in there. Import time library, if I can spell library. And then we could use that down here. We could, for example, in this little while loop, which is doing the counter thing we saw last time, we could, for example, put in the command time.sleep, which is basically a wait command, and put a 1 in there. As you can say, it's sleep in seconds. So what we've done there is to, rather than have it print the numbers out as quickly as it can, it's now going to use the time library to actually wait a second between each one. So if we just save this and we run a final piece of code in this video, we press F5 and it'll go 1, 2, 3, 4. As you can see, it's waiting a second between each one, which means we've successfully imported and used the time library. The Python language is a great place to start if you want to learn computer programming, and I hope you found this introduction useful. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.